Hi, today we're going to be having a look at this faulty NOCO Lithium motorcycle battery. So I saw this on eBay for spares or repair. I've not came across one of these before. They sell for around about £100 and I paid £15 for it. Of course it's faulty. So I think we'll have a look at it and see if we can figure out what the problem is and hopefully repair it. Now this looks brand new. I'll just get it out of the box and figure out how the box opens. There we go. It doesn't even look like it's been installed. Let's get the box out of the way. And it's actually pretty light. I mean, you know, it's not really much weight to it at all. I should actually weigh it to find out how much it weighs. But it doesn't actually feel like it weighs a lot. We've got a little spacer on the bottom here which comes off, and it's a lithium iron phosphate battery with an output of 12.8 volts at 400 amp. Made in China and designed in the USA. So let's take these covers off and we'll grab the test meter and we'll just see what voltage it's got in, if any. Let's go into volts DC. And it said about 0.2 briefly there. But it looks dead as a dodo. Now what I might do is just hook it up to the bench power supply, see if it'll take a charge, and then we'll see if it actually does anything then. So I'm just going to hook the bench power supply up. And I'm going to set it to 14 volts. And we'll do 500 milliamps. And it doesn't appear to be drawing any current. Let's just see if we've got voltage there. Yeah, so we've got 14 volts there, but if I switch the bench power supply off, would it actually, that might have been the capacitors in the bench power supply there. Yeah, so we don't seem to have any voltage there at all. Now I did notice an Allen key at the top there, so we'll just try removing that, and I might remove these blocks here just so we can see how we actually get into it. I did notice at the bottom here there's these 4 plastic plugs, so I think you might have to get into this from the bottom, but we'll try the top first. I'll just go and grab an Allen key. Right, so this is a 5mm Allen key. So this might just end up being a teardown video if we can't repair it, but we'll have a look. Let's see what's under here then. And nothing. This just looks like some kind of, possibly a place for mounting the battery. Well, that didn't reveal anything, so these must be 4mm. Yeah, so I think I'm going to have to take these plastic plugs out of the bottom here. Right, let's see if we can get those out. Let's shift this out of the way a sec. A little dental pick here. I don't know if we'll be successful with that or not. I think I might have to drill those out, or drill a hole in them, and then see if we can screw a screw into them or something, possibly. Right, I'm just going to pause the video and see if I can get these out. So I did drill one of those out, but unfortunately there's no screws under there, so then I sort of focusing my attention to the top of the unit here, and this is where it actually joins. So this is glued all the way around the top there. You can just see remnants of the glue. So just use a bit of IPA and just bash it around with a screwdriver, just giving it a bit of a gentle persuasion, let's say. So this sort of thing around the edge, and that's it in half now. So let's have a look, see what's in it. So this looks like one of the batteries very similar that they use in their jump packs. So 12.8 volts, 3100 milliamp hours. Let's see if we've got any voltage in there. And also what I noticed as well, there's a couple of heat sinks there that look a little bit discoloured, so I don't know whether those have been getting hot and have caused the problem. But I think what we'll do, we'll check if there's any voltage in here first, then we'll probably disconnect this battery and we'll get this BMS board out of here. So I'll just get the meter in shot. Let's see what's in here. And there's about half of a volt. Right, let's disconnect this battery then. So it looks like we've got a couple of little wires here. Now that might be something like an NTC or temperature probe. I've got an array of wires here. So that'll be for monitoring each cell. It just says next to it there, cell 1, 2, 3 and 4 by the look of things. So it could be that there's a short on this BMS that's pulled the battery down, or it could just be that the battery's gone flat and the BMS has refused to charge it. I'm sure we'll find out what the problem is. Let's see if we can get these plugs out. Right, well there's one out. I've obviously put some of this silicone stuff around to stop them from coming loose in transit. Let's see if that one wants to come out without removing the socket from the board. So that's those two disconnected, and we just need to undo those two now. So I'm just going to see if I can find a spanner or something to undo those. Right, back with a little 13mm ratchet. They're on. I wonder if they put some Loctite or something on there, because that took a bit getting off. Not that there's any voltage in there, so that should be okay just like that. Now I don't know whether that's, I don't know if that's turning just the other side because it doesn't want to loosen, so let's try this one. Let's see if this board wants to come out or if it's bolted. So that bolt seems to go under here somewhere. You can't actually get into that part. Yeah, you can see it goes under the plastic. So this bit is hollow. I see that's slack now, but I need to get this nut off. Right, I'm just going to see if I can get this nut off. So these nuts do actually have a little bit of Loctite on them, or a bit thread sealant. You can just see a bit of it there, a bit red. So what I did to remove this nut, I used the Rework station, just heated it up a bit, and then it just undid. So, what there's two Torx T15s and holds this board in, but this nut here, it was just spinning in this little captured part here, so that's why that wasn't coming undone. Right, let's get this under the microscope and we'll have a look over the board. So this is the main battery management chip here, which is a BQ77905, and the 08 means it's got an over voltage of 3.9 volts and an under voltage of 2.0 volts. So if the voltage of the cells goes above that, above the 3.9, it shuts it off, or if the cells drop below the 2.0 volts, the battery management switches these cells off. Let's see what else we can see. Looks like we've got a voltage regulator there. We've got a couple of current sense resistors, which I think are 0.3 milliohms, I think that is. And these are the main MOSFETs, which are used to either switch the cell to the output or not. And two are probably over voltage, and two are for charge and two are for discharge possibly. Or over voltage and under voltage. I'll have to see which pins they go to on the BMS. So they're a G013 N04. And those two are the same. So let's have a look on the other side of the board. And it's all pretty much blank apart from this section here, which when I've looked up the numbers on those chips, there's 4 of them. Those are charge balance ICs, and what those do, if the cell reaches this upper threshold, it then switches on this MOSFET here, which then drains the cell through these couple of resistors here, and that keeps the cells all in the same voltage range while they're charging, so it balances the cells out. And because there's 4 of these, there must be 4 cells in this pack. So that's probably the ground, and then we've got, well, that's probably the ground, and then we've got 1, 2, 3, 4. And then we've just got this little bit of circuit here, which seems to go to the NTCs. So I guess these are probably little op amps, which then send the signal through to the battery management controller. And that's pretty much it. There's not really much else on here to shout about. So in the marketing literature, it goes on about how this is, you know, better technology than old lead acid, and you know, it's better in every way. Well, it's not that much better if it stops working, if the battery goes flat and then never works again, is it? You know, it's not like if the battery runs a bit flat you can charge it up again, because it just totally switches off. So I think what we'll do, we'll try putting some voltage into the pack, we'll try charging it manually, and we'll see if we can spring it back to life. Right, I'll get the bench power supply out again. Right, I've put some tape around this wire here just so we don't short anything out, and what we plan is to charge this via the balancing connector here, because then we can charge each of the cells individually. So this is the arrangement of the connector here. We've got the 4 cells, the black wire here at the bottom's ground, and then the white wire is the first cell. So what we'll do is we'll connect the bench power supply up to these 2 points here, and then next we'll use that one as the ground, and that is the positive from the bench power supply, then that is the ground, and so on. And we're going to be charging it to we're going to be using 3.65 volts as the charge voltage, and when the cell's fully charged it should be 3.4 at resting. So let's get the bench power supply switched on and hooked up, and I'm going to use some of these DuPont connectors here. So I'll just connect that up to the ground, which is the black wire there, and then the red wire we're just going to go onto the white connection here, and then we'll switch the bench power supply on, and I've got it set to 3.65 volts at 500 milliamps, so half an amp. You can see the voltage of the cell slowly rising there. It should stabilise, and then it should rise very slowly after that. So we'll charge the first cell first, and then we'll come back when that's fully charged. So while I'm waiting for this to charge, I just thought I'd check to see if I've got any shorts, just in case something like this battery management chip has shorted out, or there's a shorted cap on the board that's drained the power out of the batteries. I'm just wondering why the batteries have gone flat. So what we've got here is we've got a 5V test pin and we've got a ground test pin. So let's just measure across those just to see. Just get the meter and shot a bit better. Yeah, and we've got K across there, so that's fine. There's no short across there. So I'm just wondering whether the batteries have just gone flat, whether it's been sat on a shelf for that long, that the batteries are just drained below the threshold, it wouldn't charge, they've just put it to one side and then they've just completely gone flat. I mean, that one wouldn't affect anything. I mean, even if the MOSFETs had shorted, it would just send power continuously, but I mean, we don't appear to have any shorts on the MOSFETs either. I was just wondering if one of the MOSFETs have shorted and it was connected to a vehicle, then that would have drained it, but that doesn't appear to be the case either. Yeah, no shorts on there or there. Right, we'll wait for this to charge and then we'll see what happens. So the voltage on the first cell is just about 3.47 now. So what I might do is just stop it there and then charge the next cells, and then we could finish it off by charging the battery the way it's normally meant to be charged via the terminals. Then we'll be able to see if the BMS is working properly as well. So I think I'm going to switch the bench power supply off there. I'm just going to move these two leads up one notch to there, and then we'll charge the next cell. Right, we'll do that one and then we'll do the same on the other two. I've brought all of the cells up to about 3.2 volts, so we'll just check there. 3.2, 3.2, 3.2 and 3.2. So that gives her a total pack voltage of 12.96. So while I was waiting for it to charge, I thought I'd look up what the specifications are on these MOSFETs, and I was actually quite impressed. I'll just bring the data sheet up. So each one of those is 40 volts at 354 amps. And they've got a very low resistance of 1.1 milliohms. So I thought that was quite impressive as well. So the next thing I think we'll do is connect this BMS back up to the battery. We'll do the negative wire first. Let's grab my little ratchet. And we'll connect the little NTC up. And I've checked the capacitors and stuff with the test meters while I was waiting as well, just to make sure that there's no shorted capacitors or anything. Right, and that one needs to go over to here. I'll just tighten that one up. And hopefully it kind of goes back together. Actually, looks like the top goes on that way. Just by the marks on the case in here. Yeah, that's it. Let's see if we have any voltage on the output now. And we do. 12.96. So what I might do now then is charge it up fully with the bench power supply via the BMS. So I'll connect the power supply up to here. I'll set it to 13.8 and we'll try charging it up fully. See if it charges up now. I'll have to take my little probe off here. volts, we'll do 13.8. And amps, I'm going to set it to the full 10 amps, I think. And it is charging, it's drawn about 6 amps, which is rapidly going down. I'll just get the power supply in shot so you can have a look. So the amps is rapidly dropping down there. So I'll leave it like that, we'll charge it up fully, and then we'll give it a real world test. I wonder if it'll start our little Kubota or something. I don't know whether it'll be big enough, but we can give it a go. One thing I thought I'd just double check, and just thought, see if there's anything getting hot on the BMS with the thermal camera. But it appears not. It appears everything seems as it should be. You can actually see some heat on the wire there. Well, I've come back and it looks like it's fully charged. Let's just check what the voltage is now. 13.7. It is dropping very slowly there. So I'm not sure whether the cells inside may have been damaged or not. I did have a quick look on the internet to see if I could see anything about these type of cells, and they seem to be pretty resilient actually. The lithium iron phosphate batteries seem to actually tolerate being discharged down to 0 volts and being woke up again. I mean, it's not advisable, but hopefully it'll be okay. So what I might do is take it over the shed and we'll try it on a vehicle and see if it starts something. I've got some gasket sealant that I can use to reseal the top on this, and there's not that much damage on it. So if you want to take one of these apart, now you know it's just epoxied all the way around here. I was looking on the NOCO site, and it was saying in the sales things how it's better than lead acid and superior technology and over 50,000 starts and 2,000 charge cycles, and it also says 5 times longer life. So I don't think they're talking about this particular one. So I thought I'd couple it up to the quad bike here. So I've just disconnected, I've got like a sprayer on the back there and a few other things. So we've got the negative terminal just down here, sorry, the positive terminal going to the quad bike there, and that's the negative one just down this side. I've disconnected the original battery there, so let's see what it does. I'll put the key in. Well, it started that up straight away. Excellent. So I think that could be it then. Like I say, I'm not sure how long the battery is going to last, whether there's any significant damage to the cells or not, or whether it's just going to work like that now for the duration. I think we'll leave it there then, so I'll see you in the next one.